So hello and welcome friends to our channel Intromake, and this is the second part of our casting process and the different designing aspects involved in this process. So first we are going through the basics. Now we have seen that with the help of pattern we make a mold, and the liquid metal is poured into the mold and we get the casting. Now this mold is made up of a sand and some other materials, and there are different methods of making the mold. So first we will see the materials. So first one, the mold is made up of a silica sand plus clay plus water. So this is called as a green sand. Okay, then the second one is silica sand plus clay, plus if we add a sodium silicate then we get a dry sand, that is dry mold. And if we use this dry or green sand plus 50% of the clay, then there is a loam sand. So this is green or dry plus 50% of clay, so that will be our loam sand. Okay, so these are the different types, and along with this some additives are added to have some properties. So first one is the sawdust or wood powder. Now this is added in order to increase the collapsibility of the mold, so it should easily collapse and removed easily. So for that purpose sawdust and wood powder is added. Then the coal powder is added to increase the refractoriness of the mold, because it has to sustain the higher temperatures. And then the starch or dextrine, then it is added to increase the strength of the mold. Okay, now we will see the different mold making processes. So first one is the hand molding. So this is manual method in which the sand is poured and ramming is done by hand, but as we know we cannot apply the same pressure with the help of hand, and that's why this mold is not having the uniform strength in all the directions. So we have to go for the machine molding. Now in machine molding we have different types. First one is the jolting. Now in case of jolting, the mold is thrown from the some height. Okay, so it is thrown from the height, and let's consider this is ground. So it just strikes on the ground, and because of the reaction force offered by the ground, it gets hardened. Now we can easily say that as it is striking on the ground, this bottom layer will get hardened, but what about the upper layer? So the strength will not be uniform all over the mold, and there might be the chances of loosening of the sand. So this is the disadvantage of this jolting process. Now the second one is the squeezing process. Okay, now in this squeezing process what we do is exactly the opposite case of the jolting. In jolting we were trying to fall the material, and because of the reaction it is getting hardened. Now in this case we are applying the pressure from the top side of the mold. Okay, so again the top layer is more hardened as compared to the other section, and we are not getting the uniform bonding in all the directions. So what we can do is combining this jolting and squeezing process. So we will combine the process so that there will be uniformity of the sand. So we will having both the cases, we will press it from the top, and we will also have the reaction force from the bottom. Okay, now the question arises that which process should we do first, whether we should go for the squeezing first or whether we should go for the jolting first. So always jolting is done first and then squeezing is done. So this is important thing. So first is jolting and then squeezing, and then the sand slinging. Now in this case the sand is thrown away with some machine, and it is slinging motion is there. So because of that the uniform bonding is there, so we get a very uniform mold in this case, but its initial cost is a higher one as the machine cost is higher one. So these are the different methods by which mold is made. Now we'll see what is core and core making. So cores are used to have a hollow sections in the product. So if we have some holes or some hollow cavities, so for that purpose we have to put a core so that material will get filled around this core and no material in the core. So core, if will there, the material will get filled outside, but this section there will not be the material, so that we can get a hollow cavity. Okay, so this is core, but this core should have some properties, otherwise it is very difficult to remove this core, because at the end we have to remove this part. So for that purpose the core should have some properties. It should be of non-metal, and it should be free from moisture, because if it has a moisture, then because of the hot liquid metal, this moisture can create holes into the casting, which is not desirable. Then it should have high strength. It should sustain the buoyancy force, which we will see in the next lecture, that how this buoyancy force is acting, and how to design this core and core prints. And it should have high collapsibility, because as I said, we have to remove this later on, because we require the hollow section here. So this is core. So that's all for the today's lecture, and in the next session we will see how these core prints are designed, then what are the chaplets and pouring basin, then runner riser, and the designing of the getting system. So until then, be safe and stay happy, and if you have any doubts, please do write into the comment section and we can discuss over there. Thank you.